Okay, so we're talking number lines on this section right here. So we'll start off with a number line. Good place to start, don't you think? Since that's what they're talking about. And let's put some numbers on our number line. A lot of times people start with 0 right in the middle. You don't always have to, but it's pretty common, so let's go ahead and do it. Now, if 0 is right here, what numbers are to the right of 0? What kind of numbers? They're positive numbers. What kind of numbers are to the left of 0? They're negative numbers, okay? So this would be positive 1, 2, and 3. This would be negative 1, negative 2, and negative 3. All right? It's pretty basic, wouldn't you agree? Watch this. What if I put a dot on one of them, like right here? All right, put a big old dot right there, and I gave it a letter. Call it P. P for point. Is that all right? So here's a word that you're going to see quite a bit, and you got to know what that word means, what they're going to ask you. It's not really hard, but they're going to say, find the coordinate. That's the word, coordinate. That means where is the point located on the number line, all right? So the word coordinate's used for a lot of different things, like GPS, right? What are your coordinates, right? You can actually plug it in there and find your latitude, longitude. That's your coordinates, right? People use the word coordinate quite often, more often than you would think, all right? So find the coordinate. That means where on the number line is that point located? Well, where's point P? Right there where that red dot is. What number is associated with that point? It's 2, that's right. So if I said find the coordinate of P, which is point P, you would say it's just 2, and that would be your answer, all right? Pretty basic, isn't it? Yeah. We're going to talk about that a little bit more, but that's a good starting point, all right, where the coordinates of these points are located. Let's do something else before we get back to the number line. This is something I think we might have talked about already, but I'm going to do it again. They have it in the book, so I'm going to talk about it. What if you're multiplying? Product means multiply, correct? It's the answer to a multiplication problem. What if I'm multiplying a positive number times a positive number? What am I always going to get? I'm always going to get a positive. It doesn't matter how big or small the numbers are. If it's a positive times a positive, it's always give me a positive. What about a negative times a negative? That's also going to be positive. So when I teach this, I usually say the same signs are always positive, right? These are both positive, the answer is positive. These are both negative, same signs, your answer is positive. So anytime you have the same signs, your answer is positive when you multiply. This also works with division as well, but they just use the word products. Not sure why they're doing this here because I think we've already done that before, but it's a good review. What if you had one positive and one negative? That's going to be a negative when you multiply those together. Does it matter which one's the bigger one, which one's the smaller one? Doesn't make any difference at all. Right? What if I had a negative times a positive? These are different signs, aren't they? Different signs are always what? Negative. All right? So that's a little review for you. Again, seems kind of odd that they would just throw that in the mix, but it's all right. It's good practice. Now, what we're going to do is we're going to graph things called inequalities. So they're not equalities. Equalities would mean something's equal to something, right? So we're graphing inequalities, so it's not equal. So let me give you a big fancy word. It's called trichotomy. You're not going to have to know that word for a test or a quiz or anything, but I think it's important to know. When we talk about inequalities, if I want to compare two numbers to each other, you have in this word, you got this whole cotomy thing, whatever that means, all right? But you do see a word that you should recognize, tri. What does that mean? 3, okay? So it's 3 of something, right? So you have three different situations, basically, all right? So if I'm comparing two numbers to each other, we'll call the numbers A and B. You have three possible outcomes when you compare those numbers. So if I compared A and B, they might be the exact same numbers. So they would be what? They would be equal to each other, right? That's one possibility. Would you agree? If I just gave you two numbers, there's a chance that those two numbers could be the same. They could be equal to each other. Well, there's another chance that A could be, let's go less than first. Is that all right? Because I was getting ready to go that way. But you could say greater than. You could say that A is less than B. That's the symbol for less than. All right, so make sure you write that down if you're not sure about it. Less than. What's your other only possible choice? So if you compare two numbers, if I give you two numbers, right, and you're comparing them, these numbers might be equal to each other. This one might be less than this one, or A might be greater than the other one. Would you agree? So that right there is greater. Yeah, you can remember the alligator, but we're in 12th grade. We don't have to remember the alligator, okay? This points to the right, doesn't it? So if it points to the right, that's bigger, right? Numbers to the right are always bigger, aren't they? This points to the what? To the left. So numbers to the left are always smaller, less than. You got it? I know the alligator eats the bigger number. We're not in 5th grade anymore, all right? So we don't have to worry about that. By the way, I usually do this. I haven't done this year because I've taught inequalities to a couple of my other classes. But an equal sign, look at an equal sign. There's the same distance between those two lines, right? If I go like this, look at down here. This would be less than. Do you see the distance between those two lines? If I took that line and I turned it, went from here, let's do this. If I went from here to here, well, let's see, you're backwards. I'm backward. So if you went from here to here, what happened? You made the distance between those two less than, didn't you? This is how they get those symbols. Started off with equal. Why? Because there's an equal distance between those two, right? You go like this. Well, there's less distance between there and what? Greater distance between there. You got it? So the point, okay, if you go from left to right, if it's pointing to the left, that would be less than. What would that be from left to right? Be greater than. Now, what if you went from right to left? Like, let's put a 3 on this left side and a 5 over here. Then 5 would be what? Greater than 3. So you could read it from right to left, right? But we speak English, we read English, so we go from left to right. So if you go left to right, this would mean 3 is what? Less than 5. Make sense? Okay, enough of that. You've seen that a million times before. And putting it on a number line. So let's go back to the number line thing again. So if you had this, and let's say we got 3 possibilities, right? Let's use A is less than B. So where would I put that on the number line? So I'm going to have 1 point for A and 1 point for B. Is this one going to be A or B on the left? This has to be A, has to, because A is what? Less than B. So it has to be to the left of B, correct? So that's what that would give you. Make sense? You could read it right to left. You could say B is what? Greater than A. Isn't that what that's saying right there? That B is greater than A? This is not A is greater than B, is it? All right, so if I looked at that graph, you would tell me that that's A is less than B, right? If you had a dot right there and you had a B right there, then A and B are on the same spot. So A would be what? Equal to B. If this wasn't A, if this was B and this was A, you could say what? You could say B is less than A, or you could say what? A is greater than B. It's the same thing. We getting that? All right. All right, this seems kind of silly to do, but it is an example. It's an example in the book, so we'll do it.
Just a reminder, if you're on part of the National Honor Society, there's a meeting during high school lunch today in Mrs. Burns' room, 204. Thank you.
All right. Let's say this and tell me if it's correct or not. what do we say? 3 is less than 7, right? Is that true? Yeah, absolutely. All right, pretty simple, like I said. Now, when you start doing negatives, though, that starts getting a little bit more confusing. But if you've dealt with negatives a while, it shouldn't be that big of a deal. So this says what? Negative 8 is greater than negative 16. Is that true? Sure, because negative 16 would be here, right? Negative 8 would be here. So negative 8 is greater than negative 16. Or you could say negative 16 is what? Less than negative 8. Read it from right to left. It means the same thing. You're saying two different things, but it means the same thing. We good with that? What about, let's compare it to 0. So let's take negative 6 and 0. I'm not even going to tell you what it is. You tell me. Negative 6 is what compared to 0? Less than. So that would be less than 0. Everybody with me on that? Let's do this. Let's go negative 8 and negative 4. Let's compare those. Negative 8 would be what? Less than negative 4, right? Because negative 8 is down here. Negative 4 is right up here. Agreed? All right. Let's compare 4 and negative 1. Compare 4 and negative 1. 4 is what? Greater than negative 1. This is kind of little kid stuff, but that's all right. Let's compare 8 and 0. 8 is what? Greater than 0. All right, enough of that. What if I said A was greater than 0? What kind of a number is A? It's a positive number, right? So if you have this, this is positive. What if A was less than 0? Then what kind of number is that? A must be negative. All right. We're just laying a groundwork here, okay? We're not doing anything real fancy, but we will in a little bit. Let's do this one last thing, and then we'll quit. It's example 2. And what if I said x is greater than 4? And I want to put that on a number line. So this is our first real graphing of an inequality. So let's put some numbers in here. All right. Do I have to start with 0 in the middle and then have negatives and positives? No. If a is greater, or if x is greater than 4, here's what I usually do. I usually go like 3, 4, 5, 6, 7, 8. You see that? You could have gone to 7. You could have gone to 6 if you wanted to. I just put a handful of numbers in there. Okay. You don't have to put a million numbers in there. But if it's bigger than 4, I want a little bit of stuff on the left and most of my stuff on the right. So if I was to graph this, all right, and that's what they're going to ask you to do. They're going to ask you to graph this inequality, all right? Now, x could be any number greater than 4. So could it be 4? Why not? That's right, be equal to it. It's not equal to it, it's bigger. Okay, it's bigger than 4. 4 is not bigger than 4. What's the first number that's bigger than 4? Is it? 4.1. Is that the number right after 4? 4.1? What about 4.01? That's right after it, isn't it? That's bigger than 4. There you go. You get the idea now, don't you? Okay, we get it. All right. So 4 point a bunch of zeros. How many zeros could you put in there? An infinite. So you can't really start right here. So here's what we do. We put an open circle. You know what that open circle means? It means it does not include 4, but it means it's everything just to the right of 4. What number is just to the right of 4? It's not 5. It's going to be 4.00000 whatever, okay? But you could keep doing that forever and ever, couldn't you? All right, so we put an open circle to represent that it's not equal to 4, but it's super close to 4. But then it says x must be everything greater than 4. So that must mean I put a point here, put a point here. All these numbers are greater than 4, aren't they? But I'm not going to put a whole bunch of points there. How am I going to show that on a graph? I'm going to shade it in. I'm going to make it just a little bit fatter, all right, and shade it in like that. So there's your graph, your first inequality graph. And we're going to do a bunch more of those kind of things. I didn't quite get to the point where I wanted to give homework, so you got off easy today. All right, so we'll say no homework for tonight.
See you.
We'll see you. Have a good day.